Notes 9E, Exponential Regression. 9E says to write using technology exponential functions that provide a reasonable fit to data and make predictions for real-world problems. A patient started taking levothyroxine to treat their hypothyroidism. They started taking one white 50 micrograms tablet daily and worked their way up to one rose 112 micrograms tablet daily. Eventually, they decide to try a different medication, but their doctor says that they must wait until their levothyroxine is out of their system. It needs to be less than 4 micrograms. The following table shows the average Y amount of micrograms in the blood after X amount of days. Using the data given, create an exponential model to determine the number of days the patient to wait safely to switch to a new medication. So first of all, let's talk about how to do this on Desmos. So you'll go to desmos.com/calculator. And you're going to press the plus sign and add the table, input the data, and then you'll type in y1 tilde a times b to the x1 power. And then click log mode. So we're on Desmos, we're going to click the plus sign, add the table, and type in your values. Now that you have all the values, you're going to click underneath the table and type in your formula. Y1 tilde A times B to the X1 power. And then click log mode so you can get your correlation coefficient. So we could go ahead and write that down, especially the correlation coefficient A and B. So your formula would be Y equals 101.5 times 0.91 to the X power. Now let's do the same thing using the TI Nspire. So to do this on the TI Nspire, you would first click Vernier Data Quest. And then you want to click the table. And then if it's full with numbers, you want to clear it out first with Control W no to clear. And then input data. Click the graph. And then menu for analyze. 6 curve fit. And then 6 exponential. So let's do that. So click the green beaker, click the table, there's stuff in there, so let's press Control W no. Click the green beaker, click the table, type in your values. And then once we've double checked all the values are correct, click the graph, click menu, for analyze, 6 curve fit, 6 exponential. And then you have your values right here. Your A, your B, and your R. Go ahead and record those on your paper. So then we have Y equals 101.5 times 0.91 to the X power your correlation coefficient is about negative 0.997. The same as before. Alright, now let's talk about how to do this on Google Sheets. So go ahead and open up a new Google Sheet and follow these steps. So once you've gotten your Google Sheet open, go ahead and type in the data first. The X column first and then the Y column. From here you can calculate the exponential regression. So go into an empty cell, press equals, and then logist. You want to select your Y values, so click the first cell and go all the way down, hold down shift, click the last cell, press comma, click the node X values, and then enter. So now you have the base and the initial value. Now to find the correlation coefficient with the log mode, you have to change the Y's into a natural log of Y. Now to do that, you just click another empty box, press equals, type in ln for natural log, and then the value that you're getting the natural log of, and then press enter. And then you just want to do that for the rest of the column. So you just scroll down and drag to the end of the list. To find that correlation coefficient, you're going to press equals CORREL. Data Y will now be the ln Y. Press comma and then the same X data from before. And then press enter. And here's your correlation coefficient. It's the same as before, the negative 0.997. So on Google Sheets, we want to go to Google and put data, convert Y list into ln Y list. And you do that by putting this into this box right here. And then to get the A and the B, you do equal logist with the Y list and the X list. And then to get the correlation coefficient, you do equal CORREL, the ln of Y list, and then the X list. The reason why we have it as ln of Y is because we want to make it so that it actually turns into linear. So we have the formula Y equals A times B to the X power. We could turn the equation into linear, the Y equals A times B to the X power, by taking the ln of each side. And then we can rewrite it as ln of Y equals ln of A plus X ln of B. And then this is now linear, where ln B is the slope, and then ln A is your y-intercept. So your exponential model is going to be y equals 101.5 times 0.91 to the x power. Your y-intercept is the 101.5 and your base is the 0.91. How many days would the half-life be? Basically what that is asking for is when is y going to equal half of 101.5? So 50.75. Let's graph that on Desmos. So we'll go down here and we'll put y equals 50.75. And then now let's see where the lines intersect. Looks like it only intersects one time. It's at 7.33. So the half-life would be 7.33. How many days until the patient's blood contains less than 4 micrograms of levothyroxine? So on this one, we want to make an inequality. We're going to have 101.5 times 0.91 to the x power is less than 4. So let's write that in here. Y is less than 4. Okay, so it's any of this right here. So let's find the first day that would be. 34.198. So it'd be after 34.2 days. And we could round that up to 35 days. So after 35 days. So the conclusion here would be the patient needs to wait at least 35 days before changing to a new medication.